a very warm welcome to Deeksha Vedantu. I'm your Aditi Mam, and a lot of you guys have been asking for ray diagrams, right? You are like, Ma'am, we are having so many problems in ray diagrams. So today I am here to clear all your problems in all your ray diagrams, how to make those ray diagrams, how to make those ray diagrams clean and neat, and how to remember them as well. Okay, so in overall, we will be simplifying ray diagrams today. Okay, now let us start this video very soon, and we will start this with the very first thing, that is a basic overall view. Okay, now we are studying about optical instruments. What? Optical instruments in this chapter, that is light. Now in this we have two kinds of optical instruments. One is our mirrors, the one in which we see our reflection, and lenses through which we see things like our specs, like magnifying glass and all that stuff, right? Now, bacha, in those mirrors as well as lenses, they are further classified into two things. That is concave mirror, convex mirror, concave lens, convex lens. Now, I am assuming that up till now you are very clear, right? And you know how those looks as well. This is concave mirror. It looks like a cave, right? So it looks like a cave, right? So it's concave mirror. The other one is simply convex mirror. So the other one, the light is coming from this side, it's simply convex mirror. Then we have concave lens. Again, both sides it has two caves, right? And then convex lens, the reverse of concave. That is it. Now a very important thing, concave lens, concave mirror beta is always similar to convex lens. This is some few things that you have to remember. You can write it on your paper as well. Okay, so concave mirror is similar to convex lens. What do I mean by similar? Is it has 6 cases. Convex lens also has 6 cases. The object placement, the image placement is almost similar. Okay, now the nature of image is also same. Okay, then convex mirror and concave lens is also beta similar. Done. Now moving on, let's quickly jump to our ray diagrams. Now very first beta we are going to see, this is what, let me know, have you thought about it? Okay, this is beta concave mirror. This is concave mirror. Now concave mirror, first of all, the first thing you have to remember, it has 6 cases. Whenever you hear about concave mirror, we will say that, ma'am, it has 6 cases. Understood? And after that, we'll see every case one by one. Now, the first thing, see, first case you have to see very carefully. Okay, beta. Now, look at this. The first case is, beta, object is at where? This, you remember, object is at infinity. And the image will be where? Now, ma'am, first make the ray diagram, then we'll see now where the image is. Yes, that is important, but you have to remember things now. Right, we are past the learning age, we are in the remembering phase now. Okay, now how do you remember? This is your image. So first is very simple, right? Object is at infinity, image will be at focus. Image will be at focus. So this is the first thing you have to remember. Okay, object is at infinity, image is at focus. I'll tell you the trick, don't worry, and I suppose you know that trick, but I'll tell you, right? So first of all, our object beta is at infinity. So remember this first very carefully. Okay, object is at infinity. From infinity, rays will come parallel. From infinity, parallel rays will come. What will come? Parallel rays will come to parallel to what? Principal axis. Ma'am, what is principal axis? You should know this. The line which is passing from the center of the mirror is called principal axis. Done until now. Now my object is at infinity. So parallel rays will come. Parallel rays will come. Parallel rays will come. Parallel rays will come. Understood? And now beta, they will reflect back. This is, we know, this is a mirror, it will reflect back and it will pass from the focus. Which is the focus? This dot, ma'am, the first dot from the pole is my focus. Understood? Okay, understood. So my reflected rays, these are incident rays. My reflected rays will pass from focus. My reflected rays will pass beta from focus. Understood, everyone? Okay, very good. So my image is now where? Image is at focus, object was at infinity. Understood? See, you can see this is neat, right? You can see that this diagram is neat, right? There are so many rays. That I'm not saying that you stop drawing so many rays, but with so many rays, you have to make it very presentable, very neat and clean. Now, concave mirror, okay? Beta, as soon as you hear concave mirror, we heard 6 cases. Now, in those, we also hear that 5 okay cases and 1 a very stupid case. Right? 5 very good cases, 1 stupid case. We usually call it exception, but we will call it stupid. Because why does it have to be different? If all 6 were the same, we'll be happy. No, it has to be virtual and direct. What, ma'am? It has to be virtual and direct. Ma'am, what is virtual and direct? Okay, now listen up. Whenever real rays are meeting, see, these rays are not going like this in front of the mirror. No, they are actually coming back. The real rays are coming back. So the real rays are meeting, right? So the image will be real, right? And the image will be inverted as well. We'll understand in the next case that, okay? Because here the image will be simply point sized, right? So it is simply point sized image. So in the nature of image, we have to tell 3 things: real image or virtual image. So here real rays are meeting, real image. Be with me, I'll tell you how there is a virtual image and how can you differentiate a virtual image and a real image as well. Okay, now inverted or erect, that means ulta, that means reverse image or an upright image, right? And its size. So here all the rays are meeting at focus, so the image will be point sized at focus. Understood? Now moving on to second case. Now beta, what will happen? We know, ma'am, what will happen, ma'am? You told in your one shot as well, the object is at infinity. So we will bring that object a little bit closer to our mirror. A little bit closer to our mirror, right? So this is my center of curvature. This is my focus. The object was at infinity. Now I will bring it near the mirror, but it's still a little bit far. So the object is beyond beta C. C is your center of curvature. So your object beta now is somewhere here. Your object is somewhere here. Understood? Now beta, now what will happen? Ma'am, you said that from infinity parallel rays will come. Now remember the rules we used, right? The rules we learned, that was one ray will come parallel, pass through focus. Another ray can pass through focus and be parallel after reflecting. Right? Wait, ma'am, I don't get it. Okay, one ray, beta C, I will make it with another pretty color. This ray will go and this will be parallel to principal axis. Understood? This will be parallel to principal axis, and when it reflects back, what will happen? Ma'am, it will pass through focus. We saw it here. It will pass through focus. Okay, very good. Then ma'am, now what? All the rays will come parallel. It will also again be point sized. No. Now listen carefully. First ray comes parallel, pass through focus, right? Second ray beta, it will pass through the focus. It will pass through the focus and it will reflect back. And it will reflect back and become parallel to principal axis. And it will become parallel to principal axis beta. Done? It will become parallel to, okay, parallel to principal axis. Done. Now wherever these two reflected rays are meeting, see, these are incident rays, these are incident rays. What are the this is also incident ray. What is the reflected ray? This green one. After reflecting from the after bouncing back from the mirror, the rays will be reflected. This is reflected. This is green one is reflected. Understood? Now beta, the rays are meeting at this point. The rays are meeting at this point. Understood? Now see one thing. One more thing you have to learn is whenever this ray comes, whenever a ray from the base of this, a ray from the base of the object, it will go and it is now passing from the pole, and whatever ray is passing from the pole, it will come directly back in the same direction, 180 degree reverse, in 180 degrees. So this is it. So another ray will start from here and will come back. Okay, that means what, beta? See, the ray from the top of this is reflecting and it's here. That means the arrow side is here, right? And the base side was here. It went back, it came back. So base is again here. So base is not moving, arrow is just reversing down. Understood? Understood? Okay, so this is, beta, how our object will look like. So see carefully now what we did. Object is beyond C. Image is where? Image is, beta, beyond C and F. This is our image. This is our image. So image is beyond C and between C and F. So image is between C and F. Understood? Now is it inverted? It's inverted, right? It is reverse. So we will call it inverted. We will call it inverted. And you tell me in the comment section, is it real or not? Real or not? This is a question to you guys. Question, answer in comments. How do you have to comment? Answer in comments means you will mention the slide number. That is slide number 4 and it's a real image or it's not. This is the kind of answer you have. I actually gave you the answer, but you can still write down so that I can see which of you guys actually gave me the correct answer. Okay. Okay. Now we have real image, we have inverted image, and but beta what? We have to also give them the size. Now see carefully, is this smaller than this? Yes ma'am, it looks smaller. And also I remember it is point size. From the first case, the image is point size, right? At focus. So it will increase in size a little bit. So we will write that the image is still diminished. Ma'am, how diminished? This is point size, this is larger. Beta, we are comparing the size of image with size of object, not with the last case image, with the size of object. So what are your main answers? Your main answers, beta, are the image is diminished, the image is inverted, and the image is, beta, real. Okay, so these are the main 3 things you have to mention, just like we did here. That is real, inverted, and point sized. Understood? Understood? First 2 cases gone by. Now you will see how the next cases will go by. Okay, you will understand them in a very quick manner. Now again, this is center of curvature, focus. This is also concave mirror. Now it's the third case. Beta, what will happen in third case? Object will come more closer to the mirror, right? So it will be now at C. Object will now be at the center of curvature. And ma'am, I remember whenever the object was at center of curvature, the image also used to be at center of curvature. The image also used to be at center of curvature. So it is also at C, right? Beta, why are we also remembering the position of image? So as to make our diagram a little bit better. Okay, so as to make our diagram a little bit clean and neat, and as we already know the answer, it is not that hard for us to make the image at center of curvature. Okay, now what I can suggest you is to use that protector. Okay, because whenever you place a here and you make this hole, right, so you know that this is the radius and then half of it place a scale. Now this is focus. If you do like this, then you will easily make the image at center of curvature. But I know, of course, in exams you won't have this much time to make the mirror with your protector and all, and you can't make lenses with your protector at all, right? So you have to practice without protector as well, right? In your brain you have to practice. How will we practice? Now, okay ma'am, enough gyan. How will I practice? Now you can do one thing and you can then adjust accordingly. I'll give you a cheat sheet. Okay, now make the object at center of curvature. You did, right? Ma'am, one more thing I remember, the size of the image is also the same. The size of the image is also the same, right? So, the similar size of image you make under center of curvature of the same size at the same point. Can you see? At center of curvature, and the size of images also, beta, the size of images also same. Okay, almost same, that you can make with scale, right? Now ma'am, what do I have to do? Now beta, let's see if we make it with scale, are we able to do it? Okay, so I'll try making incident rays. Okay, I'll try making incident rays. Okay, I tried. Then this will reflect and this will come back from focus. It will pass from focus. Okay ma'am, one ray is meeting this. Actually the ray that goes from here should meet at this point, right? Okay ma'am, one is safe. Okay, let's make the another. The another ray will pass from focus, right? It will pass from focus. And now one more thing you can do, I used to do this, I'll tell you. First you draw a parallel here. Okay, so for this you'll have to use this pencil as well, but you can draw it like this, and you can do it thoda bahut upar niche as well. Okay, so if imagine it's going from, you can do this, and then use a scale to meet these points. Okay, so before making this ray, make this one the parallel one. Okay, and then just meet these 2 points and make sure they're passing from focus. Okay, so it's a cheat sheet, don't tell anyone, but don't yes. Okay, done. Now in this case I made this really good. Okay, so you don't have to use your brain this much, because see, if I make this, it's going here, it's meeting that point. Okay, so you don't need to worry. So this is how you perform when you practice. Okay, now ma'am, this is concave mirror. It is in first 5 cases the images, the real rays are meeting, so the image is real. And of course ma'am, inverted image is here, so the image is inverted. And of course ma'am, here the size is same, so we have same size of image. Done beta, understood. If you have any doubt, you can ask me in the live sessions. Okay, now moving on to next case. Now ma'am, next case we will do. Will you do? Okay, object. Now we moved the object a little bit more closer, so the object is between C and F. Now the object is between C and F, and where the image will be formed. Ma'am, remember, ma'am, stop. Okay, ma'am, after center of curvature, the image and the object reverses. The object, when the object was beyond C, the image was between C and F. Now if the object is between C and F, the image will be beyond C. The image will be beyond C. That's how much I expect you to learn. Okay, and I'll give you the trick to learn as well, don't worry, but first understand it how to make these diagrams. Okay, now beta, the object is here. Okay, and these are our what are these? These are incident rays. This one ray goes parallel and it will reflect back and will pass from focus. Very good. Okay, now ma'am, another ray, it passes from focus. Another ray will pass from focus. It passes from focus and it becomes parallel to principal axis. One ray parallel to principal axis, incident ray passes from focus. Another ray, incident ray passing through focus, becomes parallel to principal axis. Okay, and then ma'am, this becomes parallel to principal axis, so this is somewhere there they meet, and yes ma'am, we have our object. If we extend it back a little bit, extend our principal axis, that we can do. Okay, so this will be beta our image. This will be our image. Understood? See how easy it got, right? So your object is between C and F. This is your object. Your image is beyond C. Oops, this is image, and this beta is our object. Done. Again, to write the nature of the image, again ma'am, it's real rays are meeting. Again ma'am, it's inverted, I can clearly see, right? But now beta, what is the size? Ma'am, I can clearly see the size has increased, and I know that as we move towards the mirror, the size of the image increases, right? Okay, the size of the image increases. Size, not, we won't write size, we'll write enlarge. The image will be real, it will be inverted and enlarged. Understood? So this is our final convection. Done. Okay, next moving on to our final slide, that is our fifth case beta. Fifth case is, now you will do it. Now this is very easy. You will do the fifth case and I'll tell you The object now is beta what? It was between C and F, now more closer. The object is at focus. The object is at focus. And the image will be where beta? Now according to previous NCERT, we used to write the image is at infinity. But according to the new NCERT, not the literal new, very new basically. So the image will not formed. Image will not be formed. So you can simply write image is not formed. So in this they won't particularly ask you about the nature. But what you have to do, you will place the object at focus. You will place the object at focus and rays will come. Rays will come like this. And wait, let me delete it. The rays will come. It will pass from focus, right? And another ray, it will go from center of curvature. It will go from and it will come back the same part, and we see these rays are parallel. So the image will be formed at infinity or not formed. But if you have to write the answer in the exam, this is the answer in exam. Okay, now beta we are going to the sixth case. This case was easy and now you remember as well. But moving on to the sixth case beta, we have very important thing that you need to remember. Okay, now this is my sixth case. This is a stupid case. This is a stupid case. Okay, now in this what happens, the object is beta what? It is more closer to the mirror. So the object is between focus beta and pole. Understood? Object is between focus and pole. So ma'am, do you mean this is my focus, this is pole, this is center of curvature? Do you mean the object is somewhere here? Yes, the object is here. Okay, understood? Right? Now ma'am, I know all the cases we learned that one ray will go parallel, one ray will go parallel, and it will reflect back and will pass through the focus. Very good beta. This is something you remember. Okay, then ma'am, I know there in the last time I maybe forgot to tell you, but this is just a revision. So beta, one more rule is whenever a ray passes from the center of curvature, it goes back in the same direction. It goes back in the same direction. Ma'am, what does that mean? That means beta, imagine one ray is going like this. Okay, but how do you know this will pass through center of curvature? So we have done lots of experiments, and when we extended it back, when it reflected from here, right, and it passed from center of curvature. Okay, it passed from center of curvature. So you have to make this a little bit better. What should I do? Okay, let me see what can I do. How can I make this ray better? Okay, now you see Aditi ma'am's power, right? Okay, I'll show you some magic. So even it's not magic, it's just a trick you can use. Okay, so you can make this ray starting from here, use your scale, pass it through center of curvature, and then just put one arrow here. That means from here the rays is going here, it reflects back and again passes through center of curvature. Understood? Now ma'am, these are going away. Of course they won't meet in the same direction. So what do you think? These are meeting where? But we still see an image, right? So they are meeting behind the mirror. They are meeting behind the mirror beta. They are meeting behind the mirror. So you can just draw this dotted lines with the help of scale. Right? And then this is where your image will be formed. This is where your image will be formed. Done? Now beta, look what we are talking about, real images, right? So here real rays are not meeting. Real ray is this one. Real ray is going backward. Real ray is going backward. It's not meeting. So real rays are not meeting. That means our virtual rays is something that is not real. Like virtual reality games we play. It's not real. It's a virtual world, right? It's a fake world, right? So these are virtual rays. What are these? These are virtual rays beta. So a virtual image will be formed and it will be what? It's definitely enlarged. It is definitely enlarged. And beta, can you see this is not inverted, this is not inverse, right? So this is an erect image. Erect image means it is not upside down. It is exactly as a person should be. So that means, ma'am, if in the first 5 cases, if I stand in front of a concave mirror, my head will be upside down and my legs will be in the air. Yes, it will be. But in the 6th case, you will look so big, but your head will not be upside down. It will be on the upper side of the mirror only. Okay, done. And we are done with 6 cases of concave mirror. Now, ma'am, you told me how to remember the trick. Of course I will. How will I not, to my cuties? Okay, so this is a concave mirror, beta. Okay, what you have to remember? Make a concave mirror, and the first thing is make its plane axis, right? Oh, sorry, plane axis, principal axis. Okay, now what you have to remember, first write the object distance. See, this is center of curvature, this is focus. So in the first case, my object is at infinity, so I'll write it here. Okay, then the object is at beyond C. It is at beyond C. Done. Let's not write it like that. Beyond C. Done. Then the object is at C. The object is at C. Done. Then the object is between C and F. Object is between C and F. Understood? Then the object is at F. The object is at F. That is focus. Then the object is beta between pole and focus. Pole and focus. Is it clear to you? Yes, it's clear to you. Done. Now beta, remember what you have to do. Just have to write the counting in the reverse manner. Okay. But remember in the 5th cases. See, 6th case is completely different. 6th case is completely different. Okay, so we will talk about 6th case later. Every time you talk about concave mirror, you split it between 5 cases and 1 case. Okay, now what you have to do, you write 1 at the place of 5. So 1, and then 2, and then 3, and then 4, and then 5. Okay, that means beta, whenever the object is at infinity, the image will be at focus. Whenever the object is beyond C, the image will be between C and F. Whenever the object is at C, the image will be at C. Whenever the object is between C and F, the image will be between C and F. Whenever the object is at focus, the image will be beta, not formed, let's say, or at infinity. At infinity, it means not solved, right? And in 6th cases, ma'am, remember, 6th cases, the object is, the image will be on the behind the mirror. Behind the mirror. And beta, this image, right, it is always virtual. All these images are real. So here the images are real and inverted, and in this case the image will always be virtual and erect and beta enlarged. Understood? And enlarged. Now is it clear? Okay, now is it clear? Okay, great. Now moving on to next case, beta, we have convex mirror. These are convex mirrors, we can clearly see. Now it's very easy. It's been half an hour almost, ma'am. We are just at concave mirror. Arey beta, convex mirror will not even take 2 minutes. Okay, you just have to remember 2 things. First, in the first case, the object is at infinity. The object is at infinity. And in the second case, beta, the object is anywhere between infinity and pole of the mirror. So this is pole of the mirror. This is focus. This is this is one. Sorry. Now, beta, remember, towards the inner side of this circle, inner side of this mirror will be our focus. So this is our focus, this is our center of curvature, this is our focus, this is our center of curvature. Understood? Now, where the image will be formed? Ma'am, the image here will be formed whenever the object is at infinity, the image is at focus. We know that, so that remains same. But in the second case, beta, we'll see where the image is formed. Okay, you comment down where the image is formed. Until then, okay. Now, see, whenever the object is at as infinity, all the rays will come parallel. The rays will come from this side of the mirror only. Okay, the rays will come from left side of the mirror only. Okay, so all the rays are coming. But now beta, what will happen? These rays will not converge. Now what is this word? These rays will not converge beta. These rays will diverge. That means, that's why we are calling it a diverging mirror. Diverge means it is not meeting at a point, it is going away. So look, these rays, they are not meeting at a point. Okay, they will reflect back and go away, something like this. Go away. They will go away, they'll go away, they'll go away. They will go away like this. Okay, so if you extend all these rays back, beta, these rays will pass through center of, these rays will pass from focus of the mirror. Focus of the mirror. Okay, beta. Oops, wait, yes. These rays will pass from the focus, and my image will be again at focus, again it will be point sized. Done. And the image formed by a convex mirror is always virtual, because what? Because are the real rays meeting? No ma'am, they are diverging, they are going away, they are not meeting together. So virtual rays are meeting and an image is formed, that is our virtual image. Done. Now again beta, this is a part. Now anywhere between focus and pole, anywhere between pole and infinity, our object is placed, right? So rays will go parallel, one ray will go parallel, and typically ma'am it should pass through focus, right? Yes, so it will diverge in such a way, that if we extend it backwards, hear my words very clearly, it will diverge in such a way that if we extend this diverged ray back, it will pass from focus. Understood? And another ray beta, this will pass. Now we know the rays that passes from center of curvature, it goes back the same direction. So it goes from center of curvature that means, okay, look very carefully. Ma'am, how it is going through center of curvature? It is not going on the other side of the mirror. What's happening is, it is hitting this point. It is hitting this point in such a way that when we extend it backwards, it passes from center of curvature. Okay, so it goes back the same point. It goes back the same direction. Done. And then beta, this will be your final image. So beta, image is where? Image is between focus and pole. Understood? And the image is virtual and erect, just like we know, because it is erect. Obviously we can say it is upright, and real rays are not meeting, virtual rays are meeting. This is also beta a virtual ray. Okay, this is not real ray, this is also a dotted ray. Okay, so these are virtual rays that are meeting. Understood? 2 of the convex mirrors are also done and dusted, and mirror part is done. Okay, a little bit time taking this lecture is, I know, but if you see this, all your concepts will be clear. Okay, then beta, moving on to lenses, yes. Now okay, let's quickly revise it through. Okay, I have given you a sheet to revise as well. Now beta, concave mirror have 5 cases and a different case, that is 1. In 5 cases, all sizes of image is formed. That means point size, small, diminished, real, same size at center of curvature, right? So all size of image is formed. In those 5 cases, only real image is formed and only inverted images formed. Understood? This is clear, first 5 cases. Now, the last case, the 6th case beta, that is our stupid case. So, in that case, only virtual images formed, and erect images formed, and and diminished image is formed. Diminished image is formed. Did we see the size the last time? And yeah, here. So beta, can you clearly see a diminished? This is a smaller image than object, right? So the image is also diminished. Image is also diminished. Understood? Okay. Now moving on, we have lenses beta. Okay, before that, now convex mirror. Now convex mirror just has two cases. In the first case, the object is as focus, image is at infinity. Yeah, that's true. But in this, only virtual image is formed. Virtual image is formed, erect image is formed. But in here, now remember, this is an important part. Ma'am, virtual image is formed in concave mirror. Now virtual image is being formed in convex mirror as well. How will we differentiate? Now look, in the concave mirror, the virtual image formed will always be diminished. It will always be diminished. But in case of convex mirror, beta, okay, I did something wrong. No. Here it will not be diminished. It will be enlarged. My mistake. So it will be enlarged image. In concave mirror, the virtual image will always be enlarged. However, in convex mirror, the virtual image beta will always be diminished. Understood? Now moving on to lenses. Okay. Now the first lens we have, which lens is this, everyone? This lens is, ma'am, our convex lens. This is our convex lens. Very good. Now, see, this convex lens beta has again the same functions as concave mirror. So first, the object will be at infinity. The object will be beta, it will be at infinity in the first case, right? We remember, all of us remember. Now ma'am, the rays will go parallel. We know that. All the rays will go parallel. All the rays will go parallel. All the rays will go parallel. And they will reflect back and they will pass from focus. And they will reflect back and they will pass from focus. Is it true, everyone? Okay, let's move on to the next case. Should we? No ma'am, you are wrong. In lenses, there is no reflection happens. In lenses, ma'am, refraction happens. Correct. So now, these rays will not come back. These rays will pass the lens and on the second focus that we call F2, they will make and form the image. So from here, the ray will go like this. The rays will pass through focus. Second focus, the ray will pass through second focus and the ray will pass from second focus. The ray will pass from second focus. And this beta will be our image. So our image now is being formed at F2. Okay, the object is at infinity, the image is at F2. These are very important. On the left hand side we have F1 and 2F1. On the right hand side we have F2 and 2F2 beta. Okay. Now, moving on to next case. Again, the second case of concave mirror was what? The concave mirror was, now we brought the object a little bit closer and it was beyond C, but here is not C. It will be beyond 2F1. Understood? Now, beta, when it is beyond 2F1, let's make this ray diagram. Let's make its ray diagram. What will happen? See, one ray will go parallel. Ma'am, why are you still asking us? One ray will go parallel and ma'am, it will pass from focus. Very good. Ma'am, now what will the next ray go? Where will the next ray go? Now you have to remember one more thing. Now beta, just as the center of mirror was called pole, the center of this lens is called, I wrote pole. The center of this lens is called optical center, right? The center of this lens. Now, if a ray passes from this optical center, it does not show any refraction, it does not show any bending, and the ray will go direct. So if a ray passes from this optical center, it will go direct. And look at this now, where these two rays are meeting. Ma'am, these two rays are meeting here. and this is what? Between F2 and 2F2, just like between F and R, right? So, or C, sorry. So beta, your image will be where? Your image will be between F2 and 2F2. You remember the concave case where we used the object at, where is it? The object C. The object was beyond C, right? And the image was between C and F. But now the object is beyond 2F1, that is our C in this case, and the image is between F2 and 2F2. Just like that case, right? A little bit difference is there. Refraction, C, 2F1. Here we have two focuses, two center of curvatures. There we only had one focus and one center of curvature. Okay? Okay, next case, tell me fast where the object will be. The object will be, ma'am, at 2F2. Very good. Here the object will be, not 2F2, it will be at 2F1. Very good, very good. 2F1. Now, ma'am, where the image will be? Ma'am, according to our previous calculation, at 2F1, that means the image will be again at 2F1. No, in this case, the image will be at 2F2. Okay, that's the difference. The image will be at 2F2. Understood? Ma'am, show me. This is 2F1. Okay, now the rays will go. One ray will go parallel and another ray will pass through optical center. Okay, and let me change the color. Okay, so this ray will refract and will pass through F2. Another ray will go straight and they will meet at 2F1. And we have this as our object. This as our object. Okay, so you do some third party work here to make it exactly at 2F2, okay? But you get the point, right? And beta, all these images are what? All the images of convex mirror are always real and inverted, right? Just like concave mirror, these are always real and inverted. We can clearly see it's inverted, right? And here the real rays are meeting. Here the real rays are meeting. They are not reflecting back. The real rays are going there, right? So here is also, it is real and inverted. Here we wrote, right? Oh no, we didn't. Okay. Now beta, here the object is smaller, so the image is diminished. The object is smaller, just like concave mirror beta, exactly same like concave mirror. Okay, now, and this is again same size as object. Done. Now moving on to next case. Now ma'am, we are bringing the image more closer. So the object will be closer. So the object will be between somewhere here 2F1 and F1, right? It will be between 2F1 and F1. So where the image will be? Ma'am, again according to my calculation, according to concave mirror, it should be beyond 2F2. Okay, now let's make the diagram. So object is somewhere here, right? Okay, ma'am, let's make this incident ray. This is the incident ray. Okay, and then it will pass from focus. Very good, ma'am, very good. Okay, then we will make another ray that is passing from optical center. And beta, it is it is meeting beyond 2F2. Okay, we will extend it and it is meeting beyond 2F2. Understood? Okay, and the image formed is again beta, it is real, it is inverted, and can you clearly say how large it is? So image is enlarged. Understood? Okay, moving on beta, we have the fifth case. We have the fifth case, is it? Yeah, fifth case. Okay, we have the fifth case beta, that is the object is at F1. Understood? So object is at F1. Okay, ma'am. Then ma'am, will again do this. We'll make one ray parallel and it will pass from F2, the focus. And ma'am, the another ray will pass through optical center. Okay. and ma'am, these are not going parallel, but these should go parallel. These are almost parallel. Okay, so ma'am, these are parallel rays. These are parallel rays, so they will never meet. So the image will not be formed. It will not be formed. Understood, beta? The image will not be formed. Done? Now come back to the sixth case. Ma'am, again a stupid case. A stupid case. We have to remember it because it is stupid case. Okay. Now ma'am, in this the object is where? The object is between now F1 and pole. No ma'am, there is no pole in lenses. There is optical center. So it is between F1 and optical center. So this will be your object, right? Okay ma'am, let's make the rays. One goes parallel and it passes from focus. Okay, another will pass through optical center. Okay ma'am, these are not even parallel, they're drifting apart. Again we will extend them backwards. We will extend them beta backwards. If I extend this backward, it will go somewhere like this. If I extend this backward, it will go something like this. And the point where they meet, this point, the point where they meet will be our new object beta, and this will be an erect object, just like the sixth case of concave mirror. And now beta, our image will be, it will be behind the lens, behind the lens beta. Okay, and it is formed somewhere after F1. Okay, done beta. Okay, these are the 6 cases of convex lenses. Okay, now moving on to next, that is our concave lens. This is now beta our concave lens. Concave lens. Now what will happen? This is similar to convex mirror. Ma'am, but that has only 2 cases. Exactly, this will also have just the 2 cases. First case is object is at infinity. The image will be where? Image will be, ma'am, simply at focus. Exactly, image will be at focus. But here is a little glitch. Not glitch, a twist. Now the image is at focus, image is at infinity, so all the rays will be coming parallel, all the rays will be coming parallel, all the rays will be coming parallel, and this is also parallel. Now ma'am, in lenses we saw that all the rays coming parallel meet at F2, so it will be same at concave lens as well, right? So it will be same at convex lens. Should I just do this? Should I just do this? I can't, right? Because of what reason? Because ma'am, concave lens is not a converging lens. It is a diverging lens. It is a diverging lens. Ma'am, what does that mean? That means the images will not meet. They will refract. They will go away from each other. They will go away from each other. Away from each other. Okay, then where will the image will be formed? The image will be formed beta when we extend these behind. Easy. When we extend these behind, we will see they are passing from focus. Ma'am, this focus and this parallel image, ma'am, what is happening, ma'am? This is beta physics. This is the circle of life, and you have not chosen physics yet, but it's good actually. It's not this bad. If you practice, you will see it is really good. Okay. So this is your focus. So image will be where? Now ma'am, image is at not F2. In convex lens it was F2. The image is at F1 only now. It is F1, right? And ma'am, are real rays meeting? No ma'am, real rays are not meeting. So the image will be, it will be virtual and it will be erect. Okay, now let's see the second, and we'll see about the erect part. Again, now the object is anywhere between, it is anywhere between optical center and infinity. So this is my optical center. Okay, now let's quickly make our object. Okay ma'am, let's place our object somewhere here. Okay, sure. Now one ray will go parallel and it's not converging, it will diverge, and if we extend them backwards, it will pass from focus, ma'am. Okay, great. let me do this. Okay, right, so done. Now ma'am, where's the next ray? Next ray will pass through optical center. What else? So another ray will pass through optical center. What else? Right, so this where these two rays are meeting is beta your image, is your image. Now your image is between optical center and F1. Your image beta is between optical center and F1. Understood? Understood everyone? Okay, and your image is virtual and my image is definitely erect and my image is small, and my image is small. Understood? All the cases of concave mirror, convex mirror, concave lens, convex lens, everything is done. Okay, done. These are all your ray diagrams. Let's just quickly practice the image formation. Wait. Okay, so we had convex lens, right, and we had concave lens. We had concave lens. In this we have beta 5 cases and 1 stupid case. Now out of these 5 cases, all sizes of images are formed. The images were formed on right hand side of the lens. Right hand side of the lens, right? This was the lens and all the images were formed here. This was image. So this is right hand side of lens. This is left hand side of the lens. Okay. And what else? We have real and inverted images. Done. In the 6th case, ma'am, this is stupid case. In this, the image is formed on left hand side of the mirror lens. Okay, so in this the image is virtual, it is erect, and beta it is very large. Image is very large. Now beta concave lens. Ma'am, concave lens looks like this and it has 2 cases. It always makes virtual image. It always makes erect image. It always makes a diminished image. Diminished image. Always. Just like Professor Snape. Okay, and what I was going to tell you, yeah, in concave lens beta, the image is always formed on the left hand side, right? In convex lens, however, only 1 stupid case is left hand side. All the 5 images are on the right hand side. Understood? Okay, now that is it beta for this video. In this video we covered everything, all cases of mirrors, all cases of lenses, concave mirror, convex lens, their sign conventions and everything. Object is always on the left hand side, the images according to our ray diagrams. Okay, so you practice them again and again and again, ask your doubts. I will come live for this as well. Okay, do not worry, and I'll meet you in the next video. Tata, bye bye.